Hello friends, this is my 13th lecture in Signal System series. My name is Nishtha Verma. So the topic which I am going to cover in this lecture will be convolution of fixed length signal and convolution of discrete time signal. Here I am taking one numerical on fixed length signal. Here xt is given, yt is xt and ht are given. We know that convolution formula is yt minus infinity to infinity x tau h t minus tau d tau. So because xt and here x tau is needed, so we can change t into tau. The signal will remain same. And ht minus tau means h tau is given here. We have to plot h minus tau. H minus tau it will be nothing but mirror image of the signal. So it will look like this. 0, 2t will come here. 1 magnitude, it is tau. So now we know that in convolution we have to find the overlapping area while shifting h minus tau with either minus t or plus t. So we know that if we shift h minus tau signal at the left side, there will be no overlapping area. So definitely t we have to take positive so that there will be little overlapping area. So in this question there will be three conditions of overlapping. First condition will be when small t will be less than capital T. Second condition will be when small t will be equal to capital T. And third condition will be when small t will be greater than capital T but less than 3t. Why 3t? Because 2t and t, the full total length will be 3t. Because after 3t there will be no overlapping area. So if I will plot for this signal, my x tau will remain same for all the three conditions. X tau is length is 0 to t, magnitude is 1, and it is tau axis. Here the signal x tau will remain same. It is 0 to t, 1 magnitude. Here again x tau and the signal will remain same, 0 to t, 1 magnitude. Now we have to plot h minus tau with t shifting. So suppose here the signal I said t is less than capital T, so my h minus tau will look like this. So suppose t is coming here, so we don't know what point it is. Suppose it is x. We know that length of the total signal is 2t. So definitely small t minus x will be equal to 2t. So you can say x is nothing but t minus 2t. So this point x point is nothing but t minus 2t. So here you will see the overlapping area will be 0 to t. In the same way, when I say t is equal to capital T, so here the signal will look like this. Small t will come over here. This time will remain t minus 2t only because t is variable. So that's why the overlapping area will be from 0 to capital T. And here I am saying small t is lying between capital T to 3t. Suppose it is 2t, it is 3t. So it is less than 3t and it will come here up to here. So the overlapping area at this point is nothing but same, t minus 2t, because small t is variable. So this will be your overlapping area. So when we will find the convolution, we have to integrate. The integration limit we are getting from the overlapping areas. So overlapping area is from 0 to t in first case. In second case, the overlapping area is 0 to capital T. In third case, the overlapping area is t to t to capital T. Because it is a pulse signal, so magnitude will remain 1 d tau. Here 1 into 1 d tau. Here 1 into 1 d tau. So definitely its value will be small t. After integration, its value will be capital T. And its value will be upper limit minus lower limit will be t minus 2t. So it will be t minus t plus 2t. So it will be 3t minus t. So because we have to calculate the total overlapping area, so we have to add the three values. So total answer will be addition of all the three, that is equal to small t plus capital T plus this. So we will see that t and t will be cancelled out. So your final answer will be, I'm writing t plus capital T plus 3t minus t. So minus t will be cancelled out. So final answer will be 4t only. So this is your convolution result. Now coming for convolution of discrete time signal, as we did for continuous time signal, in discrete time signal, instead of t we are taking n, because in discrete signals number of samples are present. So if impulse signal is there, so definitely the response will be impulse response. And because convolution we always find for discrete LTI system, that is LTI, that is linear time invariant system. So if it is time invariant, so if we shift at the input signal, so definitely there will be shift in the output, because it follow homogeneity property. So that's why if I multiplied with xk constant at the input side, the same constant should come at the output side also. So xk is coming at the output response also, because LTI system also follows superposition theorem. So if we will sum up from k minus infinity to infinity, so we will write the input side like this. So our output response will be this one only. So we can say that the final convolution for discrete time signal will be, here summation will come, because these are discrete samples, we can't take integration. So yn is equal to minus infinity to infinity xk hn minus k. So now for solving discrete time signal, there are two methods. First is using the formula and second is shortcut method. So it depends. If in a engineering semester exam the numerical is of 10 marks, then definitely we have to follow the formula method. And if we are solving for gate exam, for competitive exam, so definitely we go for a shortcut method. So I'm going to explain both the methods, but the result for both the methods will remain same. So here hn or xn and hn is given to you, and we know that the convolution formula for discrete time signal is nothing but yn is equal to summation n is equal to minus infinity to infinity xk h n minus k so this is the formula. So we know that xk will not change, so we can write x0 x1 x2. Here it will be x minus 1 x minus 2. So our xk is, because at 0 the pointer is showing at 2 value, so 2 will come over here. At x1 its value is 3, at 1 minus 1 its value is 0, other samples are 0. So because here we have to plot hn minus k, first we will write hk signal is given to you at 0 position, one sample is there, at minus 1 it is one sample and other value are 0. So definitely h minus k is needed. So h minus k means mirror image, so the signal which is present at minus 1 will come at the plus 1 side. So it will be look like this only. So now we always remember how many samples we have to calculate how many samples will be present at the output side after convolution. So for that we know the length of the signal is 3 and length of the signal is 2. So always it is equal to length of first signal, that is n1 plus n2 minus 1. So here it is 3 plus 2 minus 1, which is equal to 4. So at the output side 4 samples will come. So h minus k we have calculated. Now suppose h1 minus k we have to calculate, means h minus k is going to shift towards right side. So this signal will become 0, this is 1, This is 1, this is 1, this is 1. Always remember that we have to find the convolution of all the signal with respect to xk. So because if you find hn minus k, if you do the overlapping, here it is 0, it is 0, multiplication, here 0, and here one value is coming. But once if you shift it again, then there will be no overlapping area. So that's why we go towards h minus 1 minus k. Means h minus k, we are going to shift it towards left side. So the signal will become 1, 1, 0, 0 and 0. So because here two overlapping areas are coming, so one more can come, h minus 2 minus k. So it will become, it has become 0, it is 1, 1, 0 and 0. So now we have to multiply in first case. First we have to find y0. For y0 what we will do, we will multiply xk by h minus k. So here we will multiply these two signals and these two signals. So the answer will be y0 will be 2 into 1 plus 3 into 1, that is equal to 5 only. So in the same way for y1 will be, we will multiply xk by h1 minus k. So we will say the overlapping area will be only 3 and 1. So 3 into 1 will be equal to 3. So now we can say that here now we have value of y minus 1. So minus 1 value will be the overlapping area, if you will check, it is 1 and 2. So 1 plus 2 will be equal to 3. So similarly y minus 2 will be equal to overlapping area of hk and h minus 2 minus k will be only one sample, that is 1. So you can say that yn is nothing but different values. So at y0 it is 5, it is 1, and minus 1 it is value is 3, and at minus 2 its value is 1. So at 5 the 0 samples is coming, so it is the final answer. So now second method is a shortcut method. The same numerical I am taking, suppose h n is equal to 1, 2, 3 and the 0 sample is here. Hn is equal to nothing but 1 and 1, and here this value is. So in this method what we will do, we will make a one tabulation method xn. So different values are 1, 2, 3 xn, and hn values are 1 and 1. So now first value will be multiplied to first value, it is 1, 1 into 2, 2, 1 into 3 is 3, again 1 into 1 is 1, 1 into 2 is 2, 1 into 3 is 3. So now we will draw diagonal lines and we will find the yn. Here first sample will be 1, comma 2 plus 1 is 3, here 2 plus 3 is 5, and third sample is 3. Now the question comes where the arrow will come. So always remember that in these two signals the 0 samples value is over here. So before that how many samples are present? 1 and 2. So after 2 samples the arrow will come. So this is our 0 position. So we can check this answer is same as this answer. So it means that whatever method we use, the answer will remain same. So the topic which I am going to cover in next lecture will be the different gate numericals based on convolution for continuous time signal and discrete time signal. Thank you.